NEC classifications are defined as follows. Division 1 means hazardous conditions are present in the entire area or under normal operating conditions. Class 1 refers to flammable gases, vapors, or liquids. 1b signifies a flash point below 100 degrees Fahrenheit. 1c indicates a flash point at or above 100 degrees Fahrenheit. 1d denotes materials that present a hazard only when suspended in air. When considering wiring practices for hazard locations, electrical components must be designed and installed to withstand the hazardous atmosphere. Common methods include explosion-proof, flame-proof, pressurized, and intrinsically safe designs. Explosion-proof enclosures prevent the ignition of flammable gases or vapors inside the enclosure and are used in areas where hazardous conditions are present. Intrinsically safe circuits are designed to limit energy levels below those capable of igniting flammable atmospheres and are used in areas where hazardous conditions are present or may occur during normal operation. For guidance on this subject, refer to the National Electrical Code, specifically Chapter 500, which covers electrical installations in hazardous locations. NFPA 70E, the standard for electrical safety in the workplace, provides guidance on the safe installation and maintenance of electrical systems in hazardous locations. API-RP 500, recommended practice for electrical installations in petroleum and gas production facilities, provides industry-specific guidance for electrical installations in hazardous areas. Recommendations include the following. Firstly, follow the manufacturer's recommendations for wiring practices. Secondly, determine if the existing wiring practices meet the NEC requirements for Division 1, Class 1B hazardous locations. Thirdly, consider replacing any Class 1C or 1D components with Class 1B components. Fourthly, if possible, consult with a qualified electrician who specializes in hazardous location installations. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation. It is not law unless local jurisdictions adopt it into law. It's a comprehensive document that outlines requirements for electrical wiring, overcurrent protection, grounding, and equipment installation. NFPA 70E, the standard for electrical safety in the workplace, focuses specifically on electrical safety requirements for employees working with or near electrical equipment. It covers topics like arc flash hazard analysis, personal protective equipment, and safe work practices. API-RP 500, recommended practice for electrical installations in petroleum and gas production facilities, provides guidance specific to the oil and gas industry. It addresses the unique challenges of electrical installations in these environments, including the presence of flammable materials and the need for explosion-proof equipment. When dealing with hazardous locations, it is crucial to understand the different classifications and divisions. Class 1 locations involve flammable gases or vapors, Class 2 locations involve combustible dusts, and Class 3 locations involve ignitable fibers or flags. Divisions further categorize the likelihood of the hazardous material being present. Division 1 indicates that the hazard is present under normal operating conditions, while Division 2 indicates that the hazard is present only under abnormal conditions. Explosion-proof equipment is designed to contain an internal explosion without allowing it to propagate to the surrounding atmosphere. This is achieved through the use of robust enclosures and flame paths that cool the escaping gases below their ignition temperature. Intrinsically safe equipment, on the other hand, is designed to limit the energy available in the circuit to a level that is too low to ignite the hazardous material. This is achieved through the use of current-limiting resistors, voltage-limiting diodes, and other safety devices. Pressurized enclosures maintain a positive pressure of clean air or inert gas inside the enclosure, preventing the entry of hazardous materials. This method is often used for large equipment or control panels. Flame-proof enclosures are similar to explosion-proof enclosures, but they are designed to withstand a specific level of internal pressure and are tested to ensure that they will not allow flames to escape. When selecting wiring methods for hazardous locations, it is important to consider the type of hazard, the classification and division of the location, and the applicable codes and standards. Some common wiring methods include rigid metal conduit, intermediate metal conduit, and cable with a gas-tight or liquid-tight jacket. All electrical equipment installed in hazardous locations must be listed and labeled for its intended use. This ensures that the equipment has been tested and certified to meet the applicable safety standards. Regular inspections and maintenance are essential for ensuring the continued safety of electrical installations in hazardous locations. This includes inspecting equipment for damage, testing safety devices, and verifying that wiring methods are intact. When working in hazardous locations, it is important to follow safe work practices such as wearing appropriate personal protective equipment, using non-sparking tools, and ensuring that the area is properly ventilated. It is also important to be aware of the potential hazards and to take steps to mitigate them. Remember that Class 1, Division 1 locations are those where ignitable concentrations of flammable gases, vapors, or liquids are present continuously, intermittently, or periodically under normal operating conditions, exist frequently because of repair or maintenance operations or because of leakage, or in which breakdown or faulty operation of equipment or processes might release ignitable concentrations of flammable gas or vapor and also might cause simultaneous failure of electrical equipment. Class 1, Division 2 locations are those where ignitable concentrations of flammable gases, vapors, or liquids are present under abnormal conditions, such as failure of a container or ventilating system are present infrequently because of repair or maintenance operations, or in which flammable liquids or gases are handled, processed, or used, but in which the liquids, gases, or vapors normally are confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems or in case of abnormal operation of equipment. Class 1, Zone 0 is a location in which ignitable concentrations of flammable gases, vapors, or liquids are present continuously for long periods. Class 1, Zone 1 is a location in which ignitable concentrations of flammable gases, vapors, or liquids are likely to exist under normal operating conditions, or in which ignitable concentrations of flammable gases, vapors, or liquids may exist frequently because of repair or maintenance operations or because of leakage, or in which equipment is operated or processes are carried on of such a nature that equipment breakdown or faulty operations could result in the release of ignitable concentrations of flammable gases, vapors, or liquids and also cause simultaneous failure of electrical equipment in a manner that would cause the electrical equipment to become a source of ignition. Class 1, Zone 2 is a location in which ignitable concentrations of flammable gases, vapors, or liquids are not likely to occur in normal operation and if they do occur, will exist only for a short period, or in which volatile flammable liquids or flammable gases are handled, processed, or used, but in which the liquids, gases, or vapors normally are confined within closed containers or closed systems from which they can escape only as a result of accidental rupture or breakdown of such containers or systems or as a result of abnormal operation of equipment with which the liquids or gases are handled, processed, or used, or in which ignitable concentrations of flammable gases, vapors, or liquids are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment, or that is adjacent to a Class 1, Zone 1 location, from which ignitable concentrations of flammable gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air and effective safeguards against ventilation failure are provided. Keep in mind that different hazardous materials have different ignition temperatures and minimum ignition energies. This information is important for selecting appropriate electrical equipment and wiring methods. For example, equipment suitable for hydrogen may not be suitable for propane, and vice versa. In the United States, the National Electrical Code, or NEC, is the primary standard for electrical installations, including those in hazardous locations. Other standards, such as those published by the ISA, International Society of Automation, and the IEC, International Electrotechnical Commission, may also be relevant depending on the specific application and location. When designing electrical systems for hazardous locations, it is important to consider the potential for static electricity buildup. Static electricity can be a source of ignition in flammable atmospheres, so it is important to take steps to prevent its accumulation. This can be achieved through grounding and bonding of equipment and by using static dissipative materials. Proper grounding and bonding are essential for electrical safety in all locations, but they are especially important in hazardous locations. Grounding provides a path for fault current to flow back to the source, which helps to protect equipment and personnel from electrical shock. Bonding connects different metal parts together to equalize their electrical potential, which helps to prevent static electricity buildup. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. In hazardous locations, it is important to use overcurrent protection devices that are specifically designed for use in these environments. These devices are typically enclosed in explosion-proof housings and are designed to prevent the release of sparks or flames. Surge protection devices are designed to protect electrical equipment from voltage surges caused by lightning strikes or other events. In hazardous locations, it is important to use surge protection devices that are specifically designed for use in these environments. These devices are typically enclosed in explosion-proof housings and are designed to prevent the release of sparks or flames. Remember that electrical enclosures used in hazardous locations must be properly sealed to prevent the entry of flammable gases or vapors. The type of seal required depends on the classification and division of the location. Some common types of seals include threaded seals, O-ring seals, and potting compounds. Wiring in hazardous locations must be installed in a way that minimizes the risk of damage or accidental disconnection. This typically involves using rigid metal conduit or cable with a gas-tight or liquid-tight jacket. All wiring connections must be made in explosion-proof junction boxes or enclosures. Lighting fixtures used in hazardous locations must be specifically designed for use in these environments. These fixtures are typically enclosed in explosion-proof housings and are designed to prevent the release of sparks or flames. They may also be equipped with guards to protect the lamps from damage. Heating equipment used in hazardous locations must be specifically designed for use in these environments. This equipment is typically enclosed in explosion-proof housings and is designed to prevent the release of sparks or flames. Motors used in hazardous locations must be specifically designed for use in these environments. These motors are typically enclosed in explosion-proof housings and are designed to prevent the release of sparks or flames. They may also be equipped with thermal overload protection to prevent overheating. Control panels used in hazardous locations must be specifically designed for use in these environments. These panels are typically enclosed in explosion-proof housings and are designed to prevent the release of sparks or flames. They may also be equipped with interlocks to prevent unauthorized access. Instrumentation equipment used in hazardous locations must be specifically designed for use in these environments. This equipment is typically intrinsically safe or explosion-proof and is designed to prevent the release of sparks or flames. Communication equipment used in hazardous locations must be specifically designed for use in these environments. This equipment is typically intrinsically safe or explosion-proof and is designed to prevent the release of sparks or flames. Before working on any electrical equipment in a hazardous location, it is important to energize the equipment and verify that it is safe to work on. This can be done by using a lockout/tagout procedure. All personnel working in hazardous locations should be properly trained on the hazards present and the safe work practices to follow. This training should be documented and updated regularly. Regular inspections of electrical equipment in hazardous locations are essential for identifying potential problems before they can cause an accident. These inspections should be conducted by qualified personnel and should be documented. Any deficiencies found during inspections should be corrected promptly. A hot work permit is required for any work that may generate sparks or flames in a hazardous location. This permit must be obtained from a qualified person and must specify the precautions to be taken to prevent a fire or explosion. In the event of a fire or explosion in a hazardous location, it is important to evacuate the area immediately and to notify emergency personnel. All personnel should be familiar with the emergency response plan for the facility. It is important to maintain accurate records of all electrical equipment in hazardous locations, including the date of installation, the date of the last inspection, and any repairs or modifications that have been made. These records should be readily available for review. It is also important to stay up to date in the latest codes and standards for electrical installations in hazardous locations. These codes and standards are constantly evolving, so it is important to stay informed of the latest changes. Some additional considerations for electrical safety in hazardous locations include the use of fiber optic cables, which are immune to electrical interference and do not generate sparks, the use of wireless communication devices, which can eliminate the need for wiring, and the use of remote monitoring and control systems, which can reduce the need for personnel to enter hazardous areas. When selecting electrical equipment for hazardous locations, it is important to consider the temperature rating of the equipment. The temperature rating indicates the maximum surface temperature that the equipment will reach under normal operating conditions. This temperature must be below the ignition temperature of the hazardous material present. Static electricity is a significant concern. Bonding and grounding is key. Training of personnel is a must, and maintain detailed records. Be sure to inspect frequently and keep up with changes. These practices ensure safety.